Hello everyone, it's me Paul again and welcome back to my channel. So this video today is about the assignment for one of my units in Deakin University. It is the SIT210 Embedded System Development Unit. And the topic of this assignment today is kind of interesting, so I thought I'll make a tutorial video for you guys. So the overall picture is the abstract of what we need to do in this unit. Sorry. What we need to do in this unit is you need to use a Particle Argon right here and link it with a webhook service to read data from a sensor. And if the data from the sensor exceed an amount of threshold, or there's some change in the data that captured from the sensor, then the system, the Particle Argon here, the microcontroller, will trigger an IFTTT service to send you notifications. And notification could come in any form, like a Gmail or a mobile phone notifications. Yep. So here let's first go through the problem statement we're having. So the problem statement that I am being given is, say I have a terrarium. Say I have a terrarium in the house, and I need to keep the terrarium in sunlight for an average of 2 hours a day. So what I need to do is I need to build an embedded device that uses the particle device to measure the amount of sunlight exposure my terrarium has. So what I have to do, I need to plan to use the IFTTT service to provide a notification throughout the day when the sunlight hits my terrarium, and another notification when it stops. Yep, sunlight notification is provided by my particle device, and I can use any notification channel. So basically, all in all, what I need to do is, say example, I have a terrarium that needs some sunlight and I need to keep track of it. Exactly like that. So I need to use a particle argon or any particle devices to be able to create to attach a sensor to it, and then keep reading from the sensor. And if the sensor detect any values or exceed a threshold, then I need to create a trigger that can send the message to my phone or any other platforms, just like that. Yep, basically a particle argon reading from a sensor, and whenever something happens, send message to your devices. Okay, so seems easy, right? Let's first go through the hardware we need. First, we need the USB cable. It's gonna be USB cable to a mini USB, and a particle argon device, obviously. And then we're gonna need some jumper wires, breadboard. Well, these things all come with the particle argon kits, except for the wires. And last but not least, we're gonna need the light sensor. The light sensor. This is the light sensor right here, but it is a groove light sensor because I don't seems to be able to find any other light sensor on the market at the moment. So I'm just using this light sensor. But you can use any light sensor you have because the pin is going to be the same. So light sensor going to have 3 pin: the ground, the ground pin, the volts pin, and the signal pin. So I have wired the signal pin, this green right here, green wire. I've wired into A0 pin. I don't know if you can see. Let me adjust the brightness. There we go. So I have wired the signal pin to A0 of the particle argon, and yep, it's a pretty simple circuit. Oh, and one important thing is always remember to attach the antenna, the Wi-Fi antenna, to your particle, since this thing is capable of working online. Yep. And yeah, so that's it for the hardware setup. Again, the USB, the particle argon, some jumper wires that connect to the light sensor, and that's it. Oops, my light sensor is blinking. This means the internet is unstable. We'll come back to that later. So let's go through the code first. So the code, let me open it real quick. Here we go. So in the code, I have initialized my light sensor pin, and then I initialize a built-in LED light to help me in testing these. And then I have these two flags, sunlight detect flag and not detected flag, to run an events for once time only in a loop. It's just a flag, yeah. And then this, in the setup code, I put the pin mode for the LED to be output, because I'm gonna, like I've said before, I'm gonna need the built-in LED to test the light sensor. Yeah, so in this this big loop, the main function right here is pretty simple to understand. So first of all, I continuously reading value from the light sensor, and if the light sensor is giving value more than the threshold, I set the threshold right here to be 500. Well, 500 is actually a big number for light sensor. But like because you see my environment, it's kind of light, since if I turn the lights on for all of my monitor, and then I have this windows right here, I've closed the curtain, but it's not dark at all. It's obviously not dark at all. It's still light. It's still light. So I set it to 500 in order to avoid any unexpected sensitivity of the sensor that might cause some like sensitivity and all that. Yeah. So yeah, but later in reality, in testing, I recommend you should put it this value from around 10 to 100. Yeah, because that is like where you can actually detect the sunlight when it's rising, or any low condition light. Yeah. So always, for like back to again loop, the first thing is always reading value from the light sensor, and then the second thing is if the light sensor has sent value more than the threshold I've set up here, which means the value currently is more than 500, then it's gonna trigger a FTTT service to send me an email. Yeah, I set it to send me an email, and then this flag is like this flag help the script just to run once in the whole loop, because loop means something's keep running and running again, and I don't want to receive emails keep coming and it's gonna be spamming to my mailbox, because the sunlights keep being detected. So I just want once email to be sent when the sunlight is detected. That's why I use this flag. So if the flag is false, and it will be set to true. Yeah, and yeah, that's just how we avoid the whole thing running continuously over and over in the loop function. And in contrast, if the analog value, which is the value that's being read from the light sensor, is lower than the light threshold we set up here, 500, it's gonna send another message to, it's gonna trigger an event that send another email to your devices saying that light is not detected anymore. Yeah, that's basically it is. It's quite simple, right? Not much going on. Yeah, right now I'll have a test to see how things going, but let's see what we need to do. Okay, so first I'll need to open my mailbox. Okay, here, this is my mailbox. I'm gonna load it again. I'm gonna reload it, and yep, from the top, and keep reloading it. And as you can see from the top email, is the email from Deacon Rest is nothing like this. Is the latest email I have, right? This is the latest email, and it's from Deacon Rest. I'm just showing this to you guys because I'm gonna run the script and it's gonna send me an email. Yeah, okay. Yeah, this is the time of the latest email, 3 p.m. Yep. So now this is Particle Argon is running, and as soon as I drag this light sensor outside in the table here, it's gonna trigger an alarm. It's gonna send me an email here. Look at this. And then also the LED built-in right here is gonna light up. I'm gonna put it out in 3. Oh, it's kind of blurry. Okay, 3, 2, 1. Oh, here. Yep. And since it's out already, we will check under Gmail, and here you can see there's actually a lot of noise. Let me do it again. There's a lot of noise in the thing just popping on and off. Okay, let's do it again. Okay, so it's getting dark. Okay, refresh these things for you all to see there's no new email coming. The latest email is still the one from Deacon Dress up there. Yep. So I'm gonna drag the sensor up, and then it's gonna be in 3, 2, 1. There we go. So it is the sensors being read. So let me put my phone down real quick so I can refresh the page. Okay, I have refreshed the page, and as you can see right there, I got a new email from me. Yep, from me, and it has just sent in 4:25, which is the current time at the moment. It has just sent recently, and the email is saying that the sun is rising. The sensor has detected sunlight, look like the sun is rising. These you can set it, you can customize this notification. Yep, and now I'm gonna put this sensor back to where it was before, where there is no sunlight. So I'm gonna cover it. I'm gonna cover the sensor, and let's see what notification am I getting out of this. Boom, I'm getting another notification say that it's getting dark. From me, it's getting dark. Yep, it's getting dark. It looks like the sun is going down, or there's something blocking this light sensor. And this email has just been sent recently. Yeah, yep, that's it for the thing. So I'll go through everything one again from the beginning. So we need a cable, we need a particle argon, we need some jumper wires, and the light sensor. And then you're gonna need to go to the website called IFTTT. Then you need to trigger you need to create some like, it's called applets. Yeah, you need to create 2 applets to either to receive notifications, yep, and then link it with your webhook, your particle webhook. Yeah, it's gonna look something like this. Oh, and remember is to receive a web request with JSON payload. Yep, and then link it to your webhook. Here, they'll give you a link, and make sure you you put a link in this URL right here in webhook, and then in the code. In order to trigger the webhook, you just need to call something like particle publish and the name of the webhook. Yeah. Yep, so that's it. Yep, let me test it once again for you. So right now it's normal. I put the light sensor up here. See, the built-in light is going up, and I'm gonna reset my laptop. Here, you say that the sun is rising. The sun is rising 0 minutes ago. 0 minutes ago, the sun is rising. It's just been recently. And then I flip it back to where it was, and latest message say that it's getting dark. Yeah, again, you can customize this email in the IFTT webpage, and you can also set other mechanism of sending notification. It could be a notification you use your mobile device or anything like that. Yep, so that's it. If you have any question, feel free to leave it in the comment section, and thank you for listening. Goodbye.